Thomas. Thank you very much for taking your time here in the battery expedition vehicle.
Thank you for having me.
Yeah, you're welcome. To talk about the innovation that Limatica provides to the battery industry. Before we come to that, I want to ask you on how you found into the field of battery innovation.
I myself, I'm a measurement guy. I did development of diagnostic methods at university for 6 years. They're initially on totally different application, but switched back then. I switched to applying these things to batteries, and I recognized this heavy machinery in the lab. It's so big, so slow, so little data. So the focus was more on shrinking things down, making it faster, integrating it into battery management systems, and the challenges arising from that. And later on, there was the possibility for me to move to Thyssen to integrate that.
So maybe to understand that, so when you said you are a management guy, that was at uni, right? When you did your PhD?
I didn't do my PhD. I was working on that, but let's say the focus shifted a little. So I invested a lot of time, gave a lot of effort, but I've had the opportunity to bring my knowledge into cell production equipment.
Okay.
And so I moved.
So already in the academic phase of your career, or
yes,
just to understand this.
So I worked there for 6 years, did R&D projects at the university, lots of interesting things, and from that, sometime, maybe after 6 years at the university, I have had the possibility to move to an industrial partner, to an industry company, to integrate, bring my knowledge into cell production equipment.
Yeah.
And so I knew quite good how to do measurement systems, or how to do measurements on batteries, how to analyze these data you collected. Back then, it was always with the focus on impedance spectroscopy, so diagnosing the dynamic behavior of batteries and having a way of looking inside the cell. So it was more or less one of the, let's say, initial key aspects. Batteries tickled me, kind of, and then at the university, you always have the problem you cannot go very big. So later on, there was a possibility to move to an industry partner, a big industry player who's doing automation systems for batteries.
Can you name that?
It was Thyssen Group, Thyssen Automation Systems, and back then they were already in the business on doing battery production assembly lines for batteries, and but the goal was to increase the value chain, to go more from cell assembly to a little bit more early in the cell production step into cell production itself. And there was a big need on, let's say, closing the gap in terms of available data during cell production.
Okay.
And where we talk about where I was moving to was the formation step. So this is the step where the battery gets its initial charging. And at that point, there was a very big gap between how it was done at industrial scale and how you did this at a laboratory scale. So the tool chain was very different. The available diagnostic methods were totally different world. And so the mission was to enable series production processes with possibilities with tools, or bring tools into a cell production process you already have had available in the laboratory world for decades. Especially when you talk about impedance spectroscopy, it has been a quite standard approach for looking inside the battery for many, many years. And from my point of view...
But from a lab point of view, right?
From a lab point of view. So the complexity of the system, the time you invest in the measurement, the price of a measurement channel, all these aspects are important in the laboratory scale, but not of this big importance when you look on the sheer size of going in the gigascale.
Mm-hmm.
And so the mission at Thyssen was to enable formation equipment or bring a formation equipment to the next level, to integrate, to have this with, let's say, to add additional features, bringing impedance spectroscopy to each formation channel, so that the cell producer gets the possibility of having impedance measurements on each battery produced. So this would have been a very big game changer in the
Yeah,
cell
so, so
production.
so to leverage the EIS
Yes.
measurement from the
Yeah.
laboratory environment all the way to series
Yeah.
production, so decrease in size, decrease in costs per channel measured, correct? That
Exactly.
was the goal.
So there was very little additional effort in hardware,
Mm-hmm.
how we did this, and we already know how to do this very efficiently in terms of time, so that you can do a measurement yielding the same amount of information compared to the laboratory approaches, which
Yes.
take half an hour or more in just 5 minutes.
Mm-hmm.
So this is what we've realized there, initially with some prototypes, then with some formation chambers, and the market response was quite good.
Mm-hmm.
But from the point of view as a measurement guy, you look on the measurement process and see, anyhow, there's still this big chunk of aging afterwards. For some reason, nobody gets rid of,
Okay.
or nobody's able to get rid of it.
Okay.
And
I mean, aging is even more time than just formation that you
yeah.
reduce in time,
So
right?
formation, we're talking about timescale of hours,
Mhm.
and aging, you're talking about timescale of days to weeks.
Yes.
And when you think of a gigascale production line, you're producing 250,000 batteries per day. You have to put them somewhere. And when the formation takes days to weeks, you have to store this for roughly a month, half a month, a month. 250,000 batteries per day. It's a huge, insanely huge amount of cells.
Yes.
And during that time, as a cell producer, you have big pain with that, because the cells, you're not really sure if the cells are actually good cells at that time. So they're potentially dangerous. Insurers, they don't like the situation. And when you look on this as a measurement guy, as a guy who does development of measurement technology, you ask yourself, why is that so? Why is that? Is there
You mean the
nothing
given
else?
status of technology, production
Yeah.
technology that is available in
Yes.
order to facilitate and to enhance, to increase, to improve
Yeah.
the formation process, or then the aging process, what you're talking about now?
So the first step we already did at Thyssen, let's say like that. So we've enabled formation equipment to deliver additional data which is available in the lab.
Mm-hmm.
And so in terms of looking on the data during formation, you have the possibility to get the same type of data cell developers need to
Okay.
improve cells. So this was, from my point of view, a very important step to close, to get a faster feedback on how cell production is to be, how formation needs to be,
Mm-hmm.
how to tweak these processes. So this is, from my point of view, it was a very important step there. But still, this is, let's say, a feedback intrinsic to the cell formation process. Yeah, so you need to better understand how to do the initial charging, how to actually make it work. But
And with Limatica, I think you then went one step further to
yes,
the aging process and looked at not the hours that you are trying to save during the formation, but really look at this chunk of days
yes.
that a cell needs for aging in order to be then ready for industrial application of the product. So can you pinpoint what is the key innovation that you then came up with when you made the decision to leave Thyssen and then start with Limatica?
So we've had, let's say, as a measurement guy, you look on this and you see, why is that? So why does everybody this? Everybody knows it sucks. It's not good. It takes a huge amount of time and money. It's so slow, painfully slow. The best example is Northvolt. So they knew it's really, really problematic. And
You're talking specifically about aging now, right?
yeah, so
Mm.
they knew it costs so much time and you get so little information. Everything, every information you get from this is just how much volts did, how much did the voltage drop at that time, and that's
Mhm.
it. You do not know why. You do not know
Yeah.
what happened inside the battery. And I, for myself, I asked, and Paul. So together we sat there and asked, why is that? What is it cell producers actually are looking for? And somewhere it may click, and we said they are just what they really need is a better understanding on the intrinsic activity of a battery, what causes this, and not just having a look on the effect.
Mm.
You need a better understanding on the actual causes
Yeah.
of that.
Let me ask a quick question in between. Why are they waiting for so long? Like, why is the aging so long, and what was the problem that you wanted to solve with your solution at Limatica? Because there's a reason why cell manufacturers wait 10 days for the aging.
So currently, you can just say it like that. There's no better tool.
Mm. But I mean the physical measurement that they need to do in order to know if a cell is good after aging or not.
You can do this with proxy methods. Yeah, you just check the voltage and how does it drop over time, and you have many influencing factors, temperature changes, and so on, which affect the voltage as well. And so you need to measure for a certain period of time to be able to separate influences of voltage and intrinsic self-charge activities. And for that reason, it takes this amount of time. And on top of that, self-discharge is a very small process. It has very small impact, but it's there. It's important. It's a very important aspect of cell quality when you talk about cell quality.
Yeah.
But when you translate it back, you're talking about nanovolts per hour.
And that's why you need to wait so long in order to see that difference.
Exactly.
And where I understood your innovation kicks in from the hardware, and then from the software side, we will come to that.
Yeah.
Where you can allow this time to shrink down to minutes.
Exactly.
Right? So please elaborate on those two aspects, the issues that you solved and how the service that you provide looks.
So when we have a look there, when we have a look on this, so the initial point was you need to ask the right question. So what do you actually want to see to be able to distinguish good from bad cells? And the question is not how much does the voltage drop? The question is what is the intrinsic activity of a battery? And the intrinsic activity of a battery, you can have a look on that by just looking on the very tiny fluctuations of the battery voltage.
Open circuit
on
voltage.
the open circuit voltage. So the battery you have single cells. The cells are as they are, but they are charged to a certain amount of certain state of charge. And at that point, you have an open circuit voltage. And on top of that, due to the intrinsic activity of the battery, you have tiny variations. It looks like noise. It is noise.
So the voltage is fluctuating a little bit, you mean?
Very, very tiny fluctuations. You can think of it like a heartbeat. Yeah, it's coming from the intrinsic activity. It sits on top of the OCV, but it's not just noise, as electrical engineers just want to get rid of. It's noise with information. And to make this accessible, we needed to do everything. So you needed to develop an approach how to make this data available. So we developed the hardware, we developed the data
you can measure
processing.
those tiny voltages and fluctuations.
So
and also on the time scale frequency that you needed, right?
Yes.
So it's not about just the magnitude, but also the frequency.
Yes, it's both. So you need to be you need to have a high resolution in terms of time resolution and magnitude resolution. So it's very important to have both. And therefore we developed the hardware to do that, to capture, to make this data available, to capture data stream with that, and to send it to us to process these data later on. And the second, let's say, important component is the processing pipeline. Just looking on that noise, it looks like noise, but it's noise with information, and you need to, let's say, extract the information from that noise. So you can think of it a little bit like a stethoscope. So you have some patterns inside, and you need to make these patterns available and process these patterns. And what we do then is translate it back to some metrics our customers want to know, like self-discharge. So that's one of the pain points our customers have.
Mm.
And so the chain looks like that. We have a cell, we apply our measurement device to extract these, let's say, high resolution data stream, process,
This noise.
yeah, the noise,
Yes. Yeah.
process this data stream and translate it into a metric like self-discharge somebody can use for grading a cell good or bad.
And optimizing their processes.
Yes. So the important part is we can do this as the measurement runs.
Mhm.
So we can integrate it streamline. Currently, we do this. Let's say the most common approach right now is asynchronous. We do the measurement and we process, but we're already able to do this in a streamlining process where you can do the measurement and process as it runs. We can provide you some probabilities on your cell grading, good, medium, or bad, on your customers'
Yeah.
needs.
And I already saw in the presentation that you showed me that you have you verified your process against the measured
Yeah.
the measured values, meaning building a data point cloud where you see the correlation kind of on a one axis,
Mhm.
right? That your prediction after 15 minutes always correlate with the ones that the original measurements did in 2 weeks.
So this is how we started. So we
Yeah,
just
it's
bought
pretty
some
impressive.
cells. So we have had the additional challenge that we have had only good cells.
Yeah.
So they do not show this big variation,
Yeah.
which would make it more easy.
No,
So
but
the case at the production side
like
is
a sample, like
yeah,
a
just
graded
a
cells,
sample. So
and then verified those
yeah.
with the given measurements over 2 weeks. And
So we've had to distinguish good from good cells, or good from better cells,
yes,
or better cells from the good cells.
yeah, and this it's such a good example because it proves that you are able to provide this information on cell grading as you were elaborating right now after 15 minutes, meaning in line.
Makes it more challenging for us, but it works. Yeah.
Yeah. How more challenging? How do you mean?
Now, if you have to distinguish good from very good, or very good from the good one, it's more challenging than distinguishing a good cell from a really bad one. But let's say it's good for us because then we already there to be able to do that. So it makes us more confident here. But when we have a look on it, this is how we started. So we just bought cells from the bench at the very beginning, somewhere, and measure the cell voltage, put them into the rack, take them out, measure the cell voltage again. So exactly how the cell producers do it in their big gigascale lines. So you can do it at your lab. Yeah? And this is how we did it, measured the voltage drop over time and correlated that with our measurement data. And this is how we started then. So currently when we have new customers, we start in a similar way. They send us cells to do this initial measurements to tune our setup to their needs, and then we go over to their site.
Yes. Since you have so much insight into the current European battery production industry, because you're talking to many of those leading players, I want to talk with you about the perspective on the given status that we're in right now. You mentioned Northvolt as an example, and there are others in the field that are also shaking right now, to put it politely. How do you see the current status of our industry? And also, I mean, Limatica provides a very good solution, making the European cell production competitive to the ones from Asia and the USA by decreasing the formation time. And the question now is, how do we need to maneuver in order to get your technology into those lines and to make those lines come online up front, because this is, I see, endangered right now. How would you see the whole industry status at the moment?
So I see, when we have a look, especially at the European players, unfortunately, Northvolt was quite ambitious there, but sadly it didn't work out for them. But when I have a look on other players, they are currently either in the ramp-up phase or already producing cells for many years. And so I see that two different things, two different approaches. One of them is, let's say, I would say the classical way. They just order a line and try to do a classical ramp up, and they need to they have some lessons to learn.
Mhm. You mean following the given status quo of
Yeah,
how to produce a battery cell?
yeah.
You building up on giving production technology predominantly not existent or partially existent in Europe. I mean, we
Mhm.
could also deliver a turnkey, but not as a whole turnkey
Yeah,
supplier yet.
yeah,
So that's the one route you mean, correct?
yeah. And so usually what you see there is they're relying on standard processes. They're just repeating what the Asians do,
Mm-hmm.
more or less, but there is no significant change in the process overall. Because mainly when you have a look on that, it's Asian equipment you can
Mm-hmm.
buy
Mm-hmm.
and what they usually buy. And from my point of view, mm, I wish it would be different, because when you have to be competitive, you need to do it differently. Otherwise, you can make the same stuff as the Asians do with the same equipment.
We're just running behind,
Yeah,
right?
we
Doing
keep
the same
running behind them.
mistakes they did 10 years ago
Yes,
and having the same learning curve they had 10 years ago.
and the learning curve, in terms of learning curve, we are already behind. We need to catch up there. And from my point of view, we need to do some things differently,
Mm-hmm.
at least in terms of, let's say, process-wise, or let's say at least data, in terms of data when looking on the data. So you need to collect other data to create additional feedback loops in your production process, at least during ramp up of a production line, or when you already have a production line, to improve to get faster feedback
Yeah.
for more efficient, let's say, iteration on the cell production
Mm-hmm.
cycle, cell product, or when you need to further increase on the quality of your product. So
Yeah, I think
quality is always
all
a big
these
issue here.
issues you just touched on ramp up is really critical during the first year. Like scrap rates at around
Astronomic.
50%
Yeah.
are not very seldom, and then ending up at 5 to 10% is already quite an achievement
So it's
on
what
scrap.
we hear is, if you are really good, then you are at the 5 to 10% range.
Yes.
So, but it's for the
And in the meantime, you're losing a lot of money because you're producing scrap. And so yeah, and then there data comes into play, and then not data per se, but knowledge about the process and feeding that knowledge
yeah.
back in an iteration loop in order to optimize the process.
Time
Well,
is the key there, yeah. So you need to be
yes,
able to get the information you need as fast as possible.
and to feed it back in
Yeah,
as fast as possible.
yeah.
I mean, you want to go as far in as doing it inline, but I think only a few processes within the battery production process are really inline controlled yet.
Yeah.
And yeah, this is where we need to go. And I'm also on the search, and that's why I'm doing the expedition to find innovators who allow us to automate this whole production optimization process. At least for the formation, I think we have found someone. Our formation and aging, and you're here for aging, of course. We have found someone who can provide us some solutions there.
The important part here, let's see, when we started at the very beginning, we already knew what is important to be able to integrate something in such a production line. And so it is designed to be passive, so it's non-invasive, passive, so we can attach to any existing line. So just feed some pellets out, measure this. We do not change the state of the battery in any way. So it's a purely passive measure, like a stethoscope. You listen to the battery, its heartbeat. It's always there. You do not need to do something with the battery. And after our measurement, you can feed it back to the cell production process. That's it.
Yeah.
So from our point of view, the important thing, already existing lines have big potential, still big potential to become better. And with that knowledge, you can leverage this way more for the next generation of production lines, where you can, from our point of view, will then be able to skip aging or reduce this by quite a big amount, reduces immense amount of capex, storage, whatever comes with that.
Yeah. And I think your innovation and your knowledge that you're building up goes beyond the aging process. Can you talk about the potential that it has for electrolyte filling, for example?
So that, from our point of view, it's different applications are there. So we started at formation. So the next logical step was aging, making this work. But it's an electrical measurement, so the method itself can be applied anywhere you can electrically contact the
Yeah, but
cell.
the important thing is it's passive and
Yeah,
it does not interfere with the production process or with
yeah,
the cell chemistry in any way. And I think during the cell filling,
yeah.
it's important to not disturb in any sense, because you could alter the electrochemical processes.
So it's a must. You do not apply current. It's very critical. Yeah,
Yes.
and from our point of view, it's a big potential there. So we can apply. We will apply this within the next month as well. But electrolyte filling, very important, very critical step as well. It has a big impact on the quality of the cells. So when with our approach, we see the possibility to fine tune this more, to get a better understanding on how much time you need to wait until
wetting.
for the wetting until it's finished, and when you can start with the charging of the battery, initial charging of the battery. So this time is really critical. If you wait too long, the battery degrades as well. So
Yeah, and this is from the process perspective. But what I also see, and that's my question, from the product perspective, I mean, the amount of electrolyte that you fill in. I think this is also something you could theoretically, with your measurement, optimize also, or to some extent.
this I'm not very sure. Currently, it's mainly done via weight or volume measurements.
Yeah, but through your measurement, you know when the wetting is complete.
Yes.
So
Well, let's say we cannot say by now.
yeah,
We are quite confident that we'll be able to do so, because it's as soon as the electrical system is intact, as the electrochemical cell is, or as it became an electrochemical cell, from that point in time, we can apply this method without the risk for the battery cell manufacturer.
Okay, so really interesting what you do, and as a startup, it's also kind of thrilling to see how you maneuvering from like aging and now analyzing this new field and seeing what the potential there is. And to get ahead, I ask you the question on the European battery ecosystem and the reason why I'm doing this campaign. I want to ask you 3 questions that I ask every guest of this format on this expedition. To maneuver forward,
Yes.
what are the key challenges that you see ahead of us in order to build the European battery ecosystem?
From my point of view, ambition is there, but sometimes what is really critical, looking at on a bigger scale, is to actually do the step. Sometimes you just have to do it, and not just bringing papers, bringing that. So the risk arises from being passive and not doing the things you need to do, let's say, important game to implement an important game changer somehow, and to making and from the when you have a look on the European players and the cost structure of the European players, they have no choice of, instead of implementing innovation which leads to a technological advantage. If you do the same as the Asian players, you cannot.
It's foreseen that we will lose then.
Yes.
You mean, yeah. So
You have the
to
same
underline
equipment
this,
with higher costs.
yeah, to underline this, what you mean is taking the risk in order to innovate.
I
Right?
see.
And innovation is taking risk.
Yes.
You can see this vice versa.
There's no way around that. You need to do this. Otherwise, I will see.
So that was the
it's
challenge.
complicated.
So you see at the moment that not enough risk is taken?
Sometimes, yes. Some players do so. Mainly the smaller ones are more flexible here, so they see innovation and they are more willing to test things, especially if there are no real risk for them except for investing some days or weeks of working hours. So from the smaller players, we see this, but I hope it would be the same from the bigger players.
So shout out to the gigafactories here.
Yes, big shout out, yeah.
Let's frame this positively. What is the potential that you see Europe is unique for, and which gives us hope?
I see. So the potential is there. So you have infrastructure is there. The infrastructure is really good. You have really good people here. You have motivated people here. It's a very important thing. And the technological basis and the basis in terms of knowledge people bring from universities, it's on a very high level. So I see this as a big benefit here in Germany, in Europe in general.
Okay.
So from that point of view, I do not think that's going to be critical. I see this as a big plus. And as well from the companies we have here, we automation engineering for the production lines, for engineering companies in general, we have all the important players there.
Yeah.
But from my point of view, it's really important that there's some consortium building up to actually do the next important step, to innovate and just to try it out.
So then let me ask you the last question, final one, and sharp answer, of course. What is your advice if you would have won to our industry in order to build our ecosystem?
So innovation is just possible with finding the right players on a very important part like cell production efficiency and just try it out. Trying things out does not need the gigascale at the first step, but you need to do this either at the existing line or just do it wherever you like.
It requires
you need to do
doing. Right?
It requires doing.
Yeah. And let's motivate for that. You're a prime example with your team, and also greetings to Paul and Bastian for pushing forward. Yes. So Thomas, thank you very much for taking your time for this conversation, and looking forward on following on your route throughout the battery space.
So I'm happy to having us here for the possibility to present us. Maybe one last remark here. We are always looking for good people. So right now we are already started hiring. So if somebody has interest in that, feel free. So we are, let's say, growing in all parts. So I'm pretty sure there will be some potential there.